Hi there, James here. Gonna help you with this limit problem. So go to move with any limit problem, just substitute in whatever your variable is approaching. In this case, y is approaching 0. So in our numerator, we're gonna get 0. In our denominator, we're also gonna get 0. That means we have a common factor that should be able to get canceled out with a little bit of algebraic manipulation. Hardest part about these problems for me is figuring out what type of algebraic manipulation to use. So looking at the structure of that denominator, and granted, we could see a reciprocal of this problem too in the future, but based off of the denominator now, because we have a square root in there and that y is under that square root, we're going to be able to cancel between the numerator and denominator with that square root there. So we got to eliminate that, and we're not allowed to just square the entire thing because that would actually change its value. So go-to move for eliminating square roots is going to be by multiplying by the conjugate of whatever part has that square root in it. So in this case, it's in our denominator. So I'm going to set up to multiply by the conjugate, top and bottom of that denominator. One of the things that just kind of remember, we specifically picked the conjugate. And the reason why we picked it is because it's really easy to multiply out something with this conjugate. Right? The middle term is going to cancel out, so we're just going to be left with the first and the last terms. So it's going to eliminate that square root. We'll have a 2y plus 9, the square root, and then we're going to have a negative 3 times a positive 3, which would give us that negative 9. So we're going to get further cancellation there. Um, Something really important I want to point out to you guys when you're working, like knowing that there's going to be cancellation or some sort of common factor in the future, don't distribute immediately. So for my numerator, I'm not going to distribute that because I'm looking for a common factor. And if we're lucky, we can get away with already having that factor set for us. So by distributing, you're undoing factoring. You're doing the opposite of that. So since we're looking for factors, don't distribute immediately. If you're stuck, then of course distribute. But before you get stuck, don't do it. So our denominator gets nice, like I was saying, and then those nines are going to drop, which is going to be even nicer. And we can see that we do have a common factor of a y in our numerator and denominator. Those will cancel out. And then we can actually substitute in our y equals 0 once those y's get canceled from the top and the bottom. And then from there, it's just arithmetic. So a couple of closing thoughts on this problem is just a friendly reminder, don't distribute if you don't have to, especially since we're looking for a factored form. And then from my teaching point of view too, common mistake I see with students is that they'll drop the limit notation. And I'm a stickler for that, mostly because a limit doesn't necessarily equal a function. Here, the function does not exist at y equals 0, but the limit does. So our function is actually approaching the value of negative 21 when y equals 0, but the function itself does not exist. So annoying at your guys' level, at your point in the math career, but we do need to be very, very specific about what we're saying. So keep that limit notation, keep those equal signs, and then watch out for algebra. All right, good luck.